I'm going to show you some pictures now of a rocket. Shout rocket!
Rocket!
What this rocket's called? Space shuttle. It's launched in America. And where do the astronauts sit? They sit right at the top here, in the window. The place where the astronauts sit, like this. With all of the smoke and fumes. And does this look like smoke? Actually, it's not smoke. But it's steam. Because when the rocket engine fires, it's so hot. It's so hot that it might melt the rocket. That what they have to do is spray lots of water on the bottom of the rocket to stop it from getting hot. So that when it's moving, steam is created. This is going to be our rocket launching a long, long time ago, well, 400 years ago. And he lived where I live, in Cambridge. And he's the most important scientist the Earth has ever produced, apart from Albert Einstein. And me. His name is Isaac Newton. And he was sitting under a tree in his house. He looked up and he thought, there's something putting us down on the planet every time. Gravity is pulling us down, 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 down. If we want to go into space, we've got to have an engine. All of the time, gravity is pushing the rocket down, and you want to push the rocket down. He said, look, this is what we need, a rocket, an engine. And there's a very important law that he thought of. He thought of 3 laws, but the most important one for rockets is his 3rd law. Have you ever heard of Newton's 3rd law? No. Well, you have now. And it says this. It sounds very complicated and quite boring, really. It says, for every action, there is an equal and opposite reaction. It sounds like a poem, doesn't it? For every action, there's an equal and opposite reaction. Right. So what does this mean? Well, it's very simple. Very simple. If this is my rocket engine, and I set fire to the gases inside, and they won't go in this direction, like my flames and my arrows, this is an action, a force is being pushed in this way, and of course the equal and opposite reaction produces a force in this direction. And if we just take our rocket and put it in terms of Earth,
it will go down.
Force of the jets going down produces an equal and opposite reaction. Pitching up. So if our force is high enough and strong enough, it will push the rocket up and up and up and up. And it's, hopefully the milk's already gone, and it will push it up into space. So, how can we make this milk bottle into a rocket launching pad? Any ideas? Yes.
It's not about that. The rocket has 4 launches. The first one is when he goes up and then he breaks into bits.
Why does he break into bits? Do you know?
Like that. He said like that. Like that.
But do you know why? Because what happens is, you need to have a really, really, really big rocket to get into space because of gravity. Gravity is pushing down or pulling them.
Yeah.
So you need to have lots of fuel. And if your rocket's got to be so big, you don't want to take an empty rocket to space. You want to make it smaller and smaller, so you can go faster and faster. So what they do is they have made the rocket into various bits. And when it goes up, and when the fuel tank's empty, they go, oh, get rid of that. And then the next bit goes and get rid of that. And so they have up to 4 stages sometimes. And all they're left with in space is a tiny bit. Just imagine, this is where the astronauts sit, in the tiny bit. And that's the only thing that goes into space. And this is the bit they started with, the giant rocket. And of course that rocket goes, oh, we'll throw that away. And it flies down and parachutes open and it falls into the sea. And then they go catch it from the sea and take it back and fill it up with fuel again. So it's actually a really difficult thing to leave the planet because of gravity. So, how else do you think we can make this milk bottle into a rocket launching system? Yes. We can fill it up with water. That's a very good idea because. So we've got to push the water out very quickly so the rocket can go that way. Well, the only problem is that we're in a library. I like libraries a lot because libraries are full of books and I like books. And if I get water and books together, not a very good idea. Because these teachers are going to go, oh, you've got all my books wet. So how else might we make this go up? Yes?
I want to say quite helpful. You could make it go up by getting gas.
Yeah, gas, good idea.
And we get helium.
Helium, very expensive.
And the helium goes in.
Yeah.
And the gas comes out, but the helium takes all the space and the gas comes out and makes it goes up.
Very good idea.
And
sorry?
I want to say that they launched it in NASA, Florida.
Yeah. Florida. Yeah.
And the engine of the rocket works just like that. They've got highly flammable gas.
Yeah.
They've got helium.
That's absolutely right, and you are very clever. Now, the only problem is, I'm in your school. My boss said to me, do take those rockets with jets and fire and stuff if you're going to a school because they'll get in trouble and the teacher will complain to him and I'll be in big troubles. Muchos troubles. Alright? Yeah. A lot of trouble? Yeah, big problema, yeah, definitely. Now, the thing is, I don't have fuel, I don't have rocket, I don't have petrol, I don't have oxygen, I don't have helium, I don't have argon, I don't have hydrogen or anything. All I've got is what we're surrounded by, which is air. So how am I going to make this milk bottle full of air into a rocket launch?
Yeah. Put it inside.
Yeah, that's a good idea. So we fill it with
After we make a hole, after